This is Wednesday, and we're going to cover 5.5a, the first part of 5.5. And I have, if you're watching this online, because only 3 people are in the class, and we can say hello. 1, 2, 3. Hello.
Hello.
Right. So we're going to have our first. The math department met, and we have the decision. You're gonna have we're starting quizzes and tests. First quiz is going to be this Monday, coming Monday the 23rd, and you're going to have a 5.1 to 5.3 quiz that has been basically was supposed to happen last week, but has been postponed last Monday, this Monday, so it's going to be postponed for the 23rd. You will have your house parent or your parent or your legal guardian will have to sign a declaration form that you follow the academic honesty. If you don't have a printer to do that, what you will need to do, and I will send the instructions again written in a written form, you will have to sign, put a date, and saying that this refers to the academic honesty for the math department online testing. You will have your parents will need to sign it as you, so we can follow the protocol, and we're going to take it from there. So for the also, I'm going to starting from Monday, because I will need to start from Monday homeworks. So if anything from Monday, homeworks, quizzes, assessments, everything from Monday on, you will have to use the LMS Dropbox function and not the email function. I will enable the Dropbox function, so we eliminate the hundreds of emails that I'm receiving in terms of homework. So that's a learning process from all of us. We will do it. So I'm starting 5.5, which is finishing chapter 5 actually, which is the multiple angle and product to sum formulas. We will use, it's in 3 steps, the multiple angle formulas, the power reducing, and the half angle formulas. These formulas will be provided to you. They're always provided actually, no matter what the system. AP provides it, IB provides them, Pre-Calculus provides them. So they are used extensively by everybody, and they are provided product sum to product formulas, trigonometric formulas for applications, and that will finish our chapter. So multiple angle formulas. We will have formulas in the form 1 as you see here. You can always slow down these videos. Sine of KU or cosine of KU. You will have the power formulas with the sine squared, the half angles u over 2, and then the product sine u cosine u. Let's talk about these formulas here. First one. I think the most famous formula of all, sine of 2u becomes 2 sine u cosine u. That's the one that most people use everywhere. Next one, the cosine 2u that has 3 formats, 1, 2, and 3. Cosine of 2u becomes cosine squared of u sine squared of u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. So I want you to notice what happens. On the left side, the angle is 2u, and on the right side it becomes half of the angle. Alright? And then tangent of 2u, the third one, is 2 tangent u over 1 minus tangent squared u. So that's what we would use. So let's see the first example here. And you can, as I say, on all these videos, you can slow them down, watch them again and again. So we have 2 cosine x, no problem here, plus sine 2x. The situation here, what is different is I have a different angle from the first one. So I have sine 2x here, I have cosine x. So I will need to use the substitution formula here, and that will become 2 sine x cosine x. On this step now, you can factor the cosine, the 2 cosine x, and you have 1 plus sine x. So you have two parts, one part and a second part of the equation. So you have here 2 cosine x equals 0. So cosine x equals 0 basically. So in the answers are pi over 2 and 3 pi over 2. And then because I'm cosine, I'm going to add the 2 and pi here. And 3 pi over 2, 2 and pi here. Now, for the second one here, I have 1 plus sine x equals 0, so sine of x equals negative 1. Sine of x is negative 1 and 3 pi over 2. I'm adding 2 and pi, and you get again the same answer. I don't have to write it 2 times. Alright? So, go ahead and solve this. I'm going to stop the video for a second, if I can. Alright, so these are the formulas that you can use, so I'm pausing so you can start solving. So a suggestion is to use from the cosine 2u, the suggestion is to try to solve the problem is to use the second of the formulas. You can use the second of the formulas. Alright, so let's see how this is done. I see good progress. I heard good things here in class, so we're gonna use the second formula, this one. So it's 2 cosine squared x minus 1 plus cosine x. I don't have to do it, but I just like to do it. It's 2 cosine x plus cosine x minus 1 equals 0. So this is a quadratic. I think I have shown you the way that you can do it, but I'm going to demonstrate for the purpose of the video. So I have it on video how to do this quadratic using the Klein simultaneous 2. So you get two equations, two unknowns, main polynomial root finder. So it's 2x squared minus, plus, so I'm doing it just to demonstrate the idea, 1 minus 1 solve, and you get these two answers, but it's important not to forget, so it's 1/2 and negative 1 to factor out the a, so it's 2 times cosine equals 0, and notice I'm going to put the opposites of the root, so it's 1/2 and minus 1, so it's minus 1/2 and plus 1, minus 1/2 and plus 1, and here I'm going to multiply these and I get 2 cosine x minus 1 cosine x plus 1 equals 0. So from here I get that cosine x equals 1/2, and from here I get cosine x equals negative 1. So from negative 1 cosine x equals negative 1, I only get one answer, that x equals negative pi. Is negative pi enough here? Or do I need to do something else? Yes, what is it?
Plus 2.
So cosine x plus 2 and pi, and I see you are looking skeptical, so this is the negative one for the cosine, which is negative pi, pi. I don't know, so that's why you were looking, it's pi, that's why you were looking, oh.
Because the factoring shouldn't be cosine x minus 1.
Look at the answers. I have here minus 1, that's the root, so it's the opposite. Do you want to do it manually? I can do it manually also to see it. That's alright, let's do it manually. So I have 2y squared plus y minus 1, alright? Are you okay with this?
Yeah.
So these two numbers, 2 and negative 1 gives me negative 2. So I need a product that will give me negative 2. And I need a product that will give me 1. So I think that's, a sum that will give me 1. So that's clearly 2 and negative 1. 2 and negative 1. So if I break that, it becomes 2y squared plus 2y minus 1. It becomes 2y plus 1 minus y plus 1. So finally, if you factor it out, you get y plus 1, 2y minus 1, which is what I have. Alright, I did it manually and I did it with a calculator. But, so I get the pi here, and for the cosine 1/2, cosine 1/2 would be up here and down there. So that's pi over 3 and 5 pi over 3. So I have 3 answers altogether. X equals pi over 3 plus 2 and pi, or this, or x equals 5 pi thirds plus 2i's and pi. Infinite answers. Are we alright with all this? Amr, Jessica, and Katu?
Yes.
Yes.
Good, excellent. So let's move on. Let's see how I'm going to do this. Alright, so here I have to evaluate a function involving the double angle. So I'm trying to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta here. So 1, 2, and 3. Given that cosine of theta is 5 over 13, which is positive, but on quadrant 4, when they give you that theta is between 3 pi over 2 and 2 pi, we are more or less in quadrant 4, and that's why you see this diagram. So cosine also is adjacent over hypotenuse. So since I have 5 over 13, I have that the adjacent is 5, the hypotenuse is 13. So solving a quadratic would give me 12 for the opposite. Let's do it. I have 13 squared, which is the hypotenuse, minus 5 squared equals 169 minus 25 is 144, which is the root of 144 is 12. So that's how we have the, so the picture that you can see is this is minus, so this is 5, and this is, in reality it's going to be negative 12 because it's going down, alright? So even though the mathematics gives me 12 here, this is negative 12. So on that situation, we immediately can figure out that sine of theta, which we've been dealing with problems like that for a really long time, sine of theta is negative 12 over 13, which makes sense, which is opposite over hypotenuse, and tangent of theta, which is opposite over adjacent, is negative 12 over 5. Are we guys alright with this? So we have the three things. We have cosine of theta is 5 over 13, we have sine of theta is negative 12 over 13, and we have tangent of theta is negative 12 over 5. So to find sine of theta, cosine of theta, and tangent of theta, using the formulas that are provided here, it's not a very hard task actually. So as long as you are prepared for that, to be on this step, you will not have a problem. So let's go to sine 2 theta. You can get 2 sine theta cosine theta, so it's 2. We know the sine theta here, we know the cosine theta here, so it becomes a simple multiplication. Are we alright with this? So 2 sine theta cosine theta, so it's twice these two fractions. You put it into your calculator, you get the answer. Let's talk about the cosine to theta. You can just use 2 cosine square theta minus 1. You can use the second middle formula. So again, you use the cosine theta, which is 5 over 13. So it's 2, 5 over 13, which is 25 over 169 minus 1. So you get negative 119 over 169. And similarly, tangent of 2 theta, you're going to use the tangent theta, the last one, which is negative 12 over 5. So twice tangent theta, so twice minus 12 over 5, 1 minus tangent square theta, 1 minus negative 12 over 5 squared, and you get that fraction. Are we alright with this? So easy problem as long as the formulas are provided. So let me do that. Alright, so go ahead and find sine 2 theta, cosine of 2 theta, and tangent theta. I am assuming you will need to draw a triangle on the correct quadrant. So this gives me quadrant 1 here. So I'm going to draw a nice picture in quadrant 1, and actually the numbers are like so easy in this problem. I have theta here, and since sine of theta is opposite over hypotenuse, this is 5, this is 3, and we already know this is a 3, 4, 5 triangle. So clearly from here we can find cosine of theta and tangent of theta. So Amr, what is cosine of theta in this situation?
4 over 5.
Perfect. This is adjacent over hypotenuse. We've got 2. What is tangent of theta?
I don't know.
Okay. How do we find the tangent of? What is the acronym that we use for tangent?
Oh, sorry. 3 over 4.
Excellent. So it's opposite over adjacent. So it's 3 over 4. And now we're going to have to find first the sine of 2 theta, and we will have to find the cosine of 2 theta, and then we will have to find the tangent of 2 theta. So I'm just going to use the formulas that are given down here. So for the first, it's going to be 2 sine theta, cosine theta. So it's twice the numbers that I will just used here on the left side here. So I have 3/5 for sine theta, and then for cosine 4/5. So that becomes 24 over 25 if you multiply this. Cosine 2 theta, I always like to use the second formula, so it's going to be 2 cosine squared theta minus 1. So it's 2 times cosine, it's what Amr said, is 4/5. So 4/5 squared minus 1. So that becomes, even without a calculator, 2 times 16 over 25 minus 1 is just 25 over 25. So 2 times 16 is 32. 32 minus 25 is negative 7 over 25. Correct me if I'm wrong.
32 minus 25 is not negative 7.
It's positive 7, yes, correct. I did that on purpose to see if you were paying attention. So you were paying attention. Excellent, Julia. Yeah, Jessica, that's on video. Okay, the Jace. Sorry, I apologize. Shout out to, her name is?
Jason
Okay, her name is Julia B.
Brown.
Brown. Jessica L. Lomax. Lomax.
You knew it.
Is it Lomax or Lomax? Or is it? How do you say it?
Lomax.
Okay. Jessica Lomax. Hope I did not kill it. So tangent of 2 theta. Let me change the thing. 2 tangent of theta. 2 tangent of theta. And 1 minus tangent square theta. So here I'm going to use the fraction that K2 gave me, 3/4. So 2 times 3/4 1 minus 3/4 to the power of 2. So that becomes 6/8 and divided by 16 minus 3 is 13 over 16. So that is 6 times 16, 8 times 13. 6 is 8 with 16 is 2. 6 just stays, so 12 over 13. And hopefully there is no mistake. You can,
2 times 3, 4, 6 over 8.
yeah, it should be 6/4, correct? So 6/4. So instead of 8, I should have 4. Yes, so the whole calculation is wrong. Alright, so let's see. So it's 6/4. 16 minus 3 is 13/4. So here I get 4 with 16 gives me 4 here. So 6 times 4 over 13, 24 over 13. And double check all this arithmetic. And now let's go to a nice thingy, which is the double angles are not restricted just to double, meaning 2 theta. You can do 4 theta, 6 theta, or anything that is double. So notice, and I like asking questions like that. I'm going to be honest with you. So sine of 2 theta here, it becomes twice half of this angle. So twice sine of 2 theta cosine of 2 theta. Similarly, cosine of 6 theta, I'm going to use the formula, but I'm going to use half of 6 theta, which is 3 theta. So that's a nice feature of this formula. So let's see an example. It says, rewrite, I love these problems, rewrite sine of 3 theta in terms of sine of x. So sine of 3x, you can express this as a sum of as a sum of 2x, then use the formulas that we had for 5.4. So sine 2x cosine x cosine 2x sine x, and then use the formulas we learned today. Instead of sine 2x, you will write 2 sine x cosine x times cosine x, and cosine of 2x is going to be 1 minus sine squared x over x times sine x. I want you to pay attention to something. I want you to, and if you watch this again and again, I want you to pay particular attention to this spot that we decided to use for cosine 2x, the sine version. The reason is so I can multiply by sine. So that's an intelligent thing that you can do there. So let's go to the next step. You have 2 sine x cosine squared x plus distributive property on that step here, sine x minus 2 sine to the third power of x. And then you factor out from the you change, a smart thing again, you change cosine 2x squared x by 1 minus sine squared x on that step. That's a hard step. So instead of cosine squared x here, you will do 1 minus sine squared x. So you appear everything in terms of sine. That's what we wanted. So 2 sine x minus sine to the third power x plus sine x minus 2 sine to the third x. And then you combine likey terms or like terms. I like calling them likey terms. Then you get 3 sine x minus 4 sine to the third x. That's a beautiful situation. You can go a little more. You could also factor out the sine x here, and you can have at the end 3 minus 4 sine squared x. Are we alright with this? And you can go even more. So you can go a little more. That's a fancy difference of squares. So you get square root of 3 minus 2 sine x, and then square root of 3 plus 2 sine x. And if you had an equation, then you would solve things that you could solve. Sine x equals 0, sine x equals root root 3 over 2 and sine x equals negative root 3 over 2, which is extremely solvable. Alright? So, to me, you should go all the way up to there. So, you are lucky because you can do the same thing here. So, let me see if I can provide the formula. Yes, I can. I can move it down on the bottom so you can use it. And I'm going to give you a hint. A hint would be to use, for cosine, I would use this formula, so I don't have anything else other than cosines, and you will have to use again the Pythagorean. So go ahead, that's a quite lengthy process.